C++ variable which act as an alias. They are a variable, of course, but they will not be having memory of their own. They will just be acting as an alias to another variable. And what is the ampersand here? Ampersand basically means the address of. It's an see, in generic terms, ampersand is an address of variable. Okay, meaning ampersand has a different meaning as an operator also. So if you look at ampersand as an operator, it means address of. It is to get the address of a variable. Whereas in this scenario, when you make use of ampersand in declaration, here this is not a address of, but instead this is a reference. Okay, so that is the whole difference here. This is not the address of variable, instead it is a reference. And this is where you're passing the value of the variable, you are storing the value. And when you say rnref equal to 7, what happens is rnref is not a variable, meaning it does not have memory of its own. Since it is referring to n value here, you made it refer to n value. What happens is when you say rnref is equal to 7, n value in turn becomes 7. Instead of 6, n value after this statement will be now 7. Okay. So when you say cout n value, this will actually print 7 on the screen. And when you say n value plus plus and you say cout rnref, what we get? Of this we get 8, because rnref does not have a value of its own, address of its own. So it is whatever is being done on rnref in turn will happen to the variable it is pointing to, that is n value. Okay. And now if you want to see address of operator with this, when you say cout ampersand n value, what happens is this will actually print the address. So this is the address of operator here, which is being used, ampersand n value. Ampersand used with any variable prints the address of that variable. That is the operator. Okay. Okay. Now by default, references are const. Const meaning constant, meaning they, whatever value they are given upon, they must be given a value upon declaration, that is 1. So in the beginning when you declare them, you have to give them a value that is required. So when we say int rnref is equal to n value, they are actually giving a value to this reference, which is the variable n value. And you cannot do something like this. It has to refer to something, so this is invalid. And it cannot be redirected to another variable. That means in the beginning, if you set it to refer to n value, later on you can't make it refer to some other variable. That is another thing. So that's why they are const. So constant variables are something which will not be able to change value throughout its course. A normal variable is what? Something which can keep changing value throughout the normal execution of the course, whereas constant is the opposite of variable. Whatever value it has been assigned in the beginning, it continues to have the same value right till the end of the program. It will not be able to change its value. Okay, and what are const reference? It is possible to declare a const reference. It will not let you change the value it references. So with a const reference, you can't really change the value. So if you declare your variable as const like this, you cannot change the value. See, by default, references are const by default, but you can even set them as explicit const also. If you set them as explicitly const, then you will not be able to change the value to the reference. Meaning the variable can change the value, but not the reference. That is one thing that you must keep in mind while working with constants. Where do you typically use references? They are used for function parameters, that is one which we will see. And so here's an example. If you have to declare a structure something like this, int n value and float n value, and there's another structure where you're using this structure as this. So structures are a collection of variables put together, data structures as they are called, but they are declared using a struct keyword. With this set of statements, what is now happening is we have something as an object, as a variable also. See, something is now just like, it will syntactically it will work just like normal variable, but in its core it's actually a object. So it's a collection of variables put together, which can be of any data type, any number. So as opposed to array is also a structure. If you look at the technical aspect of it, it's a collection of variables put together, but limitation being all have to be of the same data type. That is not the case with structure. In structure, you can club together multiple variables which are of different data types, which can be an array, which can be another structure, which can be anything. So anything, you can basically club any data into a structure. So any data which is logically related to each other, you can club that together and make it a structure of it and just use it like a normal variable. Okay, so if I do something like this, struct something and two variables as part of this struct, and there's another structure. In this structure, I'm saying something as something. What happens now is as something is a variable of type something. And what is type something? Type something is a structure. So basically S something now will have int n value and float f value as part of it. S something is basically having two variables combined together. And what is other having? Other in turn is having S something. So S something is two variables and one more variable of its own. So other has three variables, and this is how you declare other outside the structure. So you can declare a variable of a structure outside that structure anywhere. So the structure ends with a block and a semicolon, and after this in main or any other structure or anywhere you plan to use these variables in this logical unit, you can create an object of it. You can create a variable of it and just start using it. So let's say we needed to work with the n value field of the something struct of s other. Normally we'd access that as s other dot s something dot value. This is how you normally access. Since something belongs to other, you have to first say within other, please look for something. Within something, please get the n value. This is the order that we follow: parent, child, and the actual member. If there are many separate accesses to this member, the code can become messy. See, there's no restriction on the number of levels of a structure. You can have 1, you can have 5. With this dot accessing the parent, child, these layers can be just too many and the code may be just too messy to understand. So in such scenarios, you can instead use a reference like this. So you can make this n value stored in a reference. So next time when you want to refer to this reference, to this value, you can just pick up that reference which is already referring to this variable and you can get the value. So if you see, it's so simple now. So this is a variable, just a new name. So instead of saying Mrs. Smith, let's say there's a order of hierarchy in our family, and I want to speak to Mr. Smith's daughter's daughter. Okay, instead of calling Mr. Smith's daughter every now and then, since I have to refer to her for n number of tasks, probably I can just call her with some name that is being given to her, Smita, or maybe Rosie, or maybe Lucy, whatever. So I just could say, okay, Lucy is Mr. Smith's daughter's daughter. Okay, and then whenever I have to refer to this daughter of Mrs. Smith, okay, I would just say Lucy. It's as good as that. So it's just an alias. A reference is an alias which is referring to which is made to refer to some variable. Okay, so the usage can be to cut on the hierarchy, cut down on hierarchy, or in functions, which is what we will see in the separate section. So thus these two statements are identical. When I say s other dot s something dot n value is equal to 5 or rn value equal to 5, it means the same thing. It's just that the code is more readable now. Okay. Alright, so I'm going to take up pass by reference immediately after this in the next section. Alright. So just be there for the continuation of this section in a separate section. Alright, see you there.